This video shows how Simulink is used to solve ordinary differential equations for a given system. Assuming that the system has these ordinary differential equations after the modeling of that system, with given information like initial concentrations of each component and the values of the rate constants of the reactions. Now, let us see what are the steps that should be followed in order to solve these ordinary differential equations using Simulink. First of all, you have to open a new file of MATLAB. From that window, you have to click on the Simulink icon that you can see it here in order to open your Simulink windows that you are going to work on. Now, when you click on that, this window will appear to you. This window, called the Simulink library, which includes different categories, different functions, blocks, and uh, symbols that can be used in solving different ordinary differential equations. Now, for our example here, the category that will be used often is the commonly used blocks, this one. Now, the blocks that are going to be used in this example are the gain block, where it's responsible of multiplication purposes, have the integrator in order to integrate the ordinary differential equations, which is the main block in solving ordinary differential equations. In addition to that, we have the summation block or the sum block that will be used either for subtraction or summation. All of these will be explained during the solution of the example. Moreover, in order to plot the ordinary differential equations, this block, which is called the scope block, will be used for this purpose. Now, let us start step by step solving the ordinary differential equations. Just to remind you about our ordinary differential equations of our system, these are dCA dt, dCB dt, dCC dt. Now, since we have three ordinary differential equations, so we need three integrator blocks. Now, going back to the workspace, now to start working, you have to open a new file here. It is called the new model. Just enlarge it in order to make it easy for solving and dragging and other things. Now, as I said, we have three ordinary differential equations, so we need the three integrator blocks. Just in order to move the block to your workspace, just click on it, press Ctrl, and just keep pressing on it and dragging at the same time. So this is the first one for the first ordinary differential equation. This is the second one for the second ordinary differential equation. And this is the third one for our third ordinary differential equation. Now, you can do format for your blocks to make it nicer or better. Now, just in order to change the color to make it easy, for the person who sees this example to trace it easily and without any difficulties. Now, to do that, just right click on the block. As you can see here, there is format, there is foreground, color, background. There are different choices, different options, but for our purpose, you can just click on the foreground color, change it to the color that you prefer, like for example blue. For the second one's the same thing. Let it be yellow. The third, it seems it's not clear, but So we can change the color again, like light blue. And the last one, you can change it to whatever color you need. Okay, so these are just for colors to make it easy for us. Now you can also change the names of the integrator in order to make it easier to see each integrator that's responsible of that specific ordinary differential equation. This can be done easy just by clicking on the integrator. Just change the name to dca dt. Same thing for the second one, just dcb dt. The last one, dcc dt. Now the line that will go out from the integrator is the solution of that differential equation. In this case, we have dca dt, so the solution will be ca as a function of t, which is the time. So in order to write on this line to make it much clearer what this line represents, so just double click on that, write ca. Similar thing for the second integrator and the third one. For the second integrator, the solution will be cb, and for the third one is cc. Now our ordinary differential equations are like dca dt, starting with the first one, just to solve it step by step. Now focusing on the first ordinary differential equation, we have dca dt equals minus k1 times ca. So we said that we have ca here, so we need to multiply ca by minus k1. So to do so, we use the other block, which is the gain block. Just same procedure as we did for the integrator, just we drag it to the workspace. Okay, and to change the constant that you're going to multiply, just double click on the gain block, write -1, since the value of k1 is just 1, so just -1, and then apply. Okay, now the product from that multiplication will be minus ca, which is minus k1 ca. So just double click on that, you will get minus ca. Now after that, so we just multiply ca times k1. Now minus k1 ca will be the input of our ordinary differential equations, because the integration of dca dt is the same as the integration of minus k1. It is the integration of minus k1 ca. So we have to let this minus k1 ca as the input of our integrator. This can be done just by clicking on that line and re-put it to be as the input of our first integrator. Now, so this is for the first ordinary differential equation. Now, to be able to plot ca profile as a function of time, just use the scope block from the commonly used blocks category. This is the scope. Just drag it as the integrator and the gain blocks we did before. So just drag this scope block. Now just connect the line of ca with the input of the scope. Now for the first order differential equation, it's ready for solution, but we need to solve all the equations simultaneously in order to plot them all in the same figure to compare to see the profile of the reactant A, the profile of the intermediate B, and the profile of the product C, how they are changing with time. Now let us move to the second ordinary differential equation, which is dCb dt. As you can see here, coming back to the ordinary differential equations, the dCb dt equals K1Ca minus K2Cb. So to do that, first of all, we have the output line, which is Cb. Just we need to multiply it by minus K2, and K2 is 2, so multiply by minus 2. Then add to it K1Ca that can be getting from the first ordinary can be taken from the first ordinary differential equation. Now let us do that. Now we have Cb, so we need to multiply it by minus K2, which is minus 2. So again, you need gain block, drag it to the workspace window, and just connect that by this one. Double click on the gain, change it from 1 to minus 2. Apply, then OK. And now the output of this multiplication is minus 2Cb, which is minus K2Cb. Now we need to add K1Ca. Now here we have what? We have minus K1Ca. So in order to use this one here, or to add it here, we have to multiply minus Ca or minus K1Ca by minus 1. So again, use another gain block here. You can double click or right click on the gain block in order to rotate it to make it just clearer. From a format, rotate block, that's it. So connect this line by the black line, and then double click on the gain, change it from 1 to minus 1 because we need to have K1Ca or Ca, and we have minus Ca, so multiply by minus 1 to get K1Ca. Now the result here is just Ca, which is K1Ca. Okay, now we need to add these together, so we need to use a new block now, which is the sum block here. Drag it from this library window to the workspace window. Now just connect these together, and thus. Okay, now this summation block, it's not only for summation, it's also for subtraction. Now in order to change the signs here, these signs, they are pluses, means that you have a summation. To change these signs, for example, you have one is minus and the other is plus, or you have subtraction, so you can change this by just double clicking on the block. Here, from the list of signs, instead of plus plus, you can say minus minus, or plus minus, or minus plus, or whatever the case that we have. But here, for our example, for our case, we have just the plus plus the summation of the two values. Now the result here will be our ordinary differential equation, second ordinary differential equation. So this one will be just Ca minus 2Cb, which is K1Ca minus 2 minus K2Cb, and K2 is 2, K1 is 1. Now we have this ordinary differential equation, so we need to input it here in order to let the integrator block to integrate it, because this is the input of our integrator block. Now same thing, if you need to plot the concentration of B as function of time, you can use the scope block here. Either you can drag it from the library window, or you can just copy it from here, from the workspace. You can do whatever you see, it's fine. Now you can just drag it here, or just copy it from the first one. Now similar thing, just you connect the line of CP, because we are going to plot CP as a function of time, so this is our solution. So just connect it here. Now moving to the last ordinary differential equation, which is dCc/dt. Let us see what was the ordinary differential equation. It was just K2 times Cp. Now we have K2 times Cp before, but we had it minus K2Cp. So just get this function and then multiply it by minus 1 to get K2Cb. Because all of these ordinary differential equations are related to each other, so that's why they should be solved simultaneously and all together. Now this one is minus K2Cb. This is what we need in the third ordinary differential equation, but we need it plus, so just multiply it by minus 1. We can copy this gain like, or just drag it from the library. I'm going to copy it here just to save time. Okay. Okay. Now this is the one, we have it here. So the result here, the result will be what? Will be 2Cb or K2Cb. Now this one will be the input of our third integrator. Still mistake. Okay. Now, okay. Now same thing, to have a plot of C as concentration of C as function of time, just copy the scope block here and connect the C as function of time here will be plotted. Now the solution is almost ready, but in order to plot, we have to enter the initial concentrations of A, B, and C. To do so, just you double click on the integrator block. As you can see here, initial condition. So for Ca, we have initial concentration 5 moles. For B and C, since they are products, so 0 moles. So just write here 5, then apply, then OK. Now for CB and CC, it's already 0, so no need to rewrite them again. Now we will have the plot of each one of them individually. So to do the plot, first of all you have to use your time range, like or your simulation stop time. Where do you need the plot to stop? At what time? So here it's 10. We can use just 5. Now click on the this icon, which is called the start simulation, in order to run your program. Just when you click on that, okay, you have to first of all to click on the first scope to show you the plot of CA as function of time, as you can see here, starting from initial concentration 5, ending up with the final concentration. If you have complete conversion, it will be 0, the final at time 5. Now same thing for B. Just click on the start simulation icon and then double click on the scope. Since B is an intermediate, which means that it's produced from the first reaction and consumed from a second reaction, so like as you can see here, it's increasing, its concentration is increasing and then decreasing again. It's produced, first reaction, then consumed. Now let us see the profile of the product C. Click on the start simulation icon, double click on the scope icon that is related to the concentration C, or the third ordinary differential equation. As you can see here, C is a product, so its concentration is increasing with time because it's produced. Now to plot all these figures together, you can use one icon or one block, which is called the mux here. Just drag these mux, drag it here to the workspace window, and just you can double click on that icon to change the number of inputs. Now we have here 3 ordinary differential equations, so we need to plot 3 plots or 3 figures. So we need here 3 inputs to the mux block. So just change this number from 2 to 3, apply, then OK. Now just you can connect the lines here, the first one to the first input, the second one to the second input, and the third one to the third input. Now to run these or to see the plots, same thing, same method. Just click on the start simulation icon to run the program, then double click on the and then in order to see, just after that mux you have a scope, the scope icon that should be here in order to plot. Okay, just click on the start simulation icon, press and then that. As you can see here, these are the 3 plots or the 3 figures that relate to the concentrations of the components A, B, C as function of time. A is decreasing, C is increasing, B is increasing, and then decreasing. Now this is the final solution, and you can at each time find the corresponding concentration, or at any concentration of any of these components you can find how much time you need in order to reach to that concentration. Now this is for plotting. In order to display your result, or to display the value exactly that at this time, which is 5, how much the value of concentration of A, B, and C, to see the exact value, just you go to another icon or to another block that will display to you the value exactly. Okay, now to display the value exactly at this time, instead of plotting or having figures, you can use another icon as I said before, which is the display icon or display plug. This plug can be found in the sinks category here. So just to drag this plug here to the workspace window and just connect the line of the solution CA to that one. Okay, and then just click on the start simulation icon, and then directly the result will be displayed here. So at time 5 at t equals 5 minutes, then this concentration or 5 hours, or depending on the range of the time, depending on the units that you have in your system. Now at this time, at the simulation stop time, the value of concentration of A is 0.03369, which is it is starting from 5 moles, ending up with 0.03369. Same thing can be done for the CB and CC. Just copy this display icon 2 times, one for the CB, one for CC. So just connect this one to the second display, this one to this display. Same thing, just you run and all the results will appear in this display plaques. Now this is the final solution of using Simulink in order to solve ordinary differential equations. Hope that you learn how to use Simulink in solving ordinary differential equation, and in my opinion, it's a very easy program that can be used easily in a good way, and the results will be displayed. The results will be obtained in an easy way and a nice way. Thank you so much, and hope to show other videos that explaining other programs and other ways of solving ordinary differential equations. Thanks a lot.